All operators on countdown 1. Flight directors go for launch.
Ignition.
Stage separation.
Producer landing burn center. Starship transformer.
Hello and welcome to Starbase, Texas. It's 5:13 p.m. Central Time, and we are 31 minutes and 38 seconds away from Starship Flight 13, the second flight test of our next generation Starship version 3. You see it there on your screen. I'm Kate Tice, Senior Manager, Quality Systems Engineering.
And I'm Nathan Commissary, a civil engineer here at SpaceX. Today, we are coming to you live from just outside the floor of Star Factory, our 1 million square foot rocket factory where we build Starship.
Yeah, I don't know what's cooler, the rocket or the place where we build it. Now, back in May, the first flight test of Starship version 3 delivered tons of data, and we'll be putting those learnings into practice today on Flight 2. All of this brings us one step closer to a fully and rapidly reusable vehicle, the key to enabling frequent flights to the Moon and Mars. Starship will also enhance Starlink's constellation and connectivity on Earth, the Moon, and beyond, while helping establish a network of AI data centers in space. Success on today's suborbital mission also opens the door for near-future orbital flights and our first attempt to catch ship on Tower 2 here at Starbase.
Pretty exciting, and this is also an exciting day for the Starlink team because we are planning to deploy 20 of the newest Starlink satellites. These sats aren't intended for operational use and will only be in space for about 20 minutes before demising, but during that 20 minutes, we're going to speed run a bunch of tests, things like deploying solar arrays, firing thrusters. We'll get into those details a little later in the show.
Yeah. Now, what Starlink engineers learned today will be essential to deploying operational V3 satellites into the Starlink constellation on future Starship flights. These larger, more powerful next-generation satellites are designed to boost orbital capacity, strengthen the overall network, and deliver a noticeably better experience for our customers.
And as we've said before, Starship is a developmental program. What we're doing today is a test. We test in flight because it's the best way to rapidly iterate the design by putting the vehicle through its paces in the actual conditions it will experience during an operational mission.
Exactly. So while we have real Starlink satellites on board, the most important payload today is data. But no matter the outcome of today's test flight, as usual, excitement is guaranteed.
Now let's head a couple of floors upstairs where Dan Hewitt is just outside the Launch Control Center. How's it going, Dan?
Hey, Nathan. It is going great. Hi to Kate as well. And hey, everybody else. I'm Dan Hewitt with SpaceX Communications. It's great to be back here with you, flying from Starbase just a couple of weeks after the last one. That was Flight 12. That was in May. We debuted a lot of new hardware, all of it flying for the first time. We're going to dig into some of the details in a minute on how that flight went, but it came with a bunch of exciting wins, some important lessons. But let's look at right now. Things are looking very good. We are not tracking any issues on the vehicle or on the pad. Just behind me in the Launch Control Center, we've got engineers on console looking at the rocket, all the systems as we count down. We have started propellant load, putting liquid oxygen, liquid methane on both stages of Starship, and we're looking good right now to launch at the open of our window at 5:45 p.m. Central Time. Weather is barely worth mentioning. We came in today with about a 90% probability of go, and we've got blue skies, scattered clouds, no scary winds. We're looking really good. Range is also currently green for launch. Reminder, we're watching the range both off the coast in the Gulf here at Starbase and also on the other side of the planet in the Indian Ocean. where we are hopefully sending the Starship in just a couple of minutes from now. All right, so before we dig into everything else for today, let's take a look back real quick at Flight 12. Now, as I said, that was the first launch of a new ship, new booster, new Raptor engine, first flight from Pad 2 here at Starbase. A lot went right, and the stuff that didn't still gave us really valuable flight data to continue building a better Starship. Like all flights, we lifted off right at the top of the window, 33 Raptor engines propelling that full stack skyward from Starbase. After we got through liftoff, booster ascent, it was Starship's turn, lit its engines for hot staging. We tried to flip the booster in a specific direction that gives us more performance. We had some differences in engine startup. We were off by about 90 degrees. We've modified that startup sequence, made it more robust to flip in the right direction. Super Heavy attempted its boost back burn. 5 engines experienced issues when attempted to relight, so we had an early end to that. We made some hardware modifications to improve relight reliability and updated our alarms and aborts. That booster attempted a landing burn as it approached the Gulf. That was unsuccessful, and it ended its flight with a hard splashdown in the hazard area. Now, while that was happening, Starship made its ascent into space. About 40 seconds after stage step, though, we lost one of those 3 Raptor vacuum engines. Still able to demonstrate our engine out capability, reach the planned suborbital trajectory. We've made some hardware operational changes on this flight and have some additional reliability improvements coming in the future. Once in space, Starship was able to deploy all 20 of the Starlink simulators, 2 modified Starlink satellites that got these brief shots of Starship in space, which was dope. We skipped the in-space burn due to engine issues, but then Starship got ready to re-enter the atmosphere. It was able to do a flap stressing test and did the maneuver to mimic the trajectory that future missions returning to Starbase are going to fly. Then it got to the pre-planned splashdown zone in the Indian Ocean, where we had drones and buoys ready and waiting. After the Raptors turned on for a flip, landing burn, Starship was in the water, and Flight 12 was in the books. So, a lot of excitement, a lot of firsts, a lot of learnings. All that set us up for round 2 today. Just getting to a launch day comes with a bunch of hurdles, a ton of problems to solve, a million little stories. Here's just a quick peek into one of those stories that was on the path to Flight 12 that we featured in the 2nd episode of our ongoing documentary, Starship.
We designed this pad to be able to support a launch every 60 minutes indefinitely. The thing about Pad 1 is it was designed to be very quick to build, it was designed to be very cheap, and it was designed to give good access to the aft end of the booster. The reason all of those things were a design goal is because we sucked at building Starship pads and we sucked at building Starships. It's like we didn't know what we were doing because it was impossible to know what you were doing because no one had ever done something like this before. The brief on that one was, hey, get something up very quick and very scrappy and very inexpensively, but that's okay. It actually needs to just be good enough for us to learn. And then if we can learn from it, we'll go build the actual good thing. I mean, the integration mechanism is the pad. The catch mechanism is the pad. All of this stuff is like integral to how the pad operates. And so the reason we call it stage 0 is literally it is the first stage of the launch process. And if it is not working, we cannot go launch. And so that certainly like raises the stakes and raises the priority and like drama whenever things go wrong on the pad. Post-static fire, as we were transiting the chopstick arms back to a lower position, we heard a loud noise out at the pad.
It's vibrating the entire tower. Something got jammed up in the chain and maybe caused it to snap. We don't really know if it's broken completely or if it's just cockeyed or buckled in some way. God, it sounds terrible. So we are in a mad dash to get that roller diagnosed and replaced as soon as possible.
The chop carriage has many rollers positioned at different parts around the tower. And when I say roller, it's literally like, imagine the world's largest bicycle chain. It's built almost exactly like a bike chain, except for it's 380 pounds, and the chop carriage weighs a lot. And so it basically broke one of those links. The chain got bound up. And the day after static fire, We called our buddies at the Cape. We had some spare units over there for building the Cape towers. We're able to hot shot to overnight the chain to us, got the old chain torn apart, got the new one put together, flew it up, and the morning after that, we were ready to rock.
With these ones, make sure we're going up. Arriba.
It was on the order of like 30 hours, 36 hours from we found the problem to had it fully back in service. On like an item that was not really designed to be very serviceable. To be able to come up with a scrappy plan, temp support it with cranes, get in there and boogie is like, that's like just classic SpaceX nonsense.
Man, I love this docuseries. It's not just behind the scenes, it's in the scenes.
It's a day in the life of working here at Starbase. It's awesome.
Yeah. Now, if that scrappy problem solving that Steyer described inspires you, if you want to be a scrappy problem solver with us and the team here, come on over and help us build the future. All right, let's meet the rocket there on the pad, Starship version 3, the most powerful rocket ever developed, ever flown.
That's right. At just over 407 feet tall, fully stacked, it is massive. Standing at the base and looking up is like looking up at a 40-story building. Insane.
It's crazy. It's a two-stage rocket. Both stages are designed to fly to Earth to return to Earth and fly again, making this the first fully reusable rocket ever. The bottom half, or the first stage, is the Super Heavy booster. That's the silver part at the bottom. It's powered by 33 of our newest iteration Raptor 3 engines. You see them there, and those run on liquid methane and oxygen. This version of Raptor provides a significant increase in thrust. With that additional thrust, fun fact, this version of Starship gets off the pad faster than our previous versions. Here you can see version 1 Starship on the left, V2 in the middle, and V3 on the right. That was our first flight of V3 on Flight 12, and that thing just leaps off the pad.
That's right. Now, Super Heavy also has 3 grid fins now, which you can think of as aerodynamic rudders to help steer during landing. They're 50% larger than on the previous booster version and are designed to support rapid reuse and a more stable atmospheric reentry.
At the top of the booster is the hot stage adapter. It's designed to protect the booster during separation and is now fully integrated for reusability.
And stacked right above that is our upper stage of the rocket, or stage 2, which is what we call ship. It's powered by 6 Raptor engines, 3 optimized for sea level performance, and 3 for the vacuum of space.
Ship's design could one day enable point-to-point transfer on Earth, meaning you could travel anywhere on the planet, just like an airplane, but this time in an hour or less. It's designed to carry massive orbital payloads, cargo and crew, to Earth orbit, the Moon, Mars, and beyond.
And for the first time, we're carrying real Starlink V3 satellites to space. For more on that, let's head out to California, where Tyler is standing by with the team in Hawthorne. How's it going, Tyler?
Hey, thank you so much, Kate and Nate. I'm Tyler Lionquist, a Starlink business analyst here at SpaceX. And for those of you who have been following along, the Starlink version 3 satellites have been designed to take full advantage of Starship's payload capacity. We're going to get our first look at those satellites today. The Starlink V3 is our next-gen satellite and includes meaningful increases in capacity, data density, and power generation. We'll be adding around 20 times the capacity into the constellation on each Starship mission as compared to the version 2 satellites that we currently launch on Falcon. That means that we'll be able to serve more people all around the world with increasingly better high-speed internet. Like all of the Starlink satellites, the V3s are built at Starlink's site in Redmond, Washington, where we already build more satellites than anyone else in the world today. The Starlink V3 sats are designed to support 1 terabit per second of downlink and 160 gigabits per second of uplink capacity. That's approximately a 10 times improvement in downlink capacity and a 22 times increase in uplink capacity from the version 2 Starlink satellite. Serving this capacity to and from customers are the satellite's upgraded phased array antennas. The upgraded phased arrays are fed by SpaceX's in-house developed chips that were designed to serve customers more efficiently in both densely and sparsely populated regions simultaneously. Each Starlink V3 satellite is also equipped with 6 high-capacity 400 gigabit space lasers. These 6 lasers will allow high bandwidth traffic to flow uninterrupted between any 2 points in the world with redundant paths across a petabit laser mesh network. And if that wasn't enough, the V3s will carry 4 quad-band radio frequency backhaul antennas. These will take advantage of the Ka, E, V, and W communication bands, allowing for an 8 times improvement in the supported capacity compared to our V2 sats. Now that's a lot of growth in capacity and capability, and as such, the new satellite design requires more power. So the solar arrays on V3 will generate approximately twice as much power as the current arrays that we fly on the V2 satellites. And they're also optimized to reduce drag in the lower orbital altitudes in which these satellites will operate. But before we operationalize these satellites, we want to put them in a flight-like environment. So these satellites were just loaded into Starship yesterday ahead of today's launch. And once deployed, the Starlink team will only have about 20 minutes of flight to speed run some tests before the sats demise in the atmosphere. Now, the team will attempt to run tests such as extending the new solar arrays and antennas, connecting with ground stations, and turning on the satellite's communication systems. And this is all part of SpaceX's iterative process to technology advancement. And from the beginning, Starlink was designed to scale rapidly and improve continuously. From production to launch and ground infrastructure, Starlink is uniquely positioned to keep pace with rising demand around the world. In fact, just this week, we rolled out the next generation Starlink kit V5, which is built for reliable, high-speed home internet.
All right, thanks, Tyler. Yeah, new Starlink kits, new Starlink satellites, and we've also got development work ongoing on an entirely new satellite, our AI data center satellite, StarMind. I actually got to sit down recently with Elon and our director of satellite engineering, Ian Dahl. We covered a whole lot of stuff. The focus really was on the 3 limiting factors to making data centers in space a reality. The first factor we really dug into was needing way more mass to orbit. We're talking megatons. And that's where Starship comes in, by combining full reusability, massive payload capacity that's essential to launch the number of satellites that we're talking about, because we plan to deploy up to 1 million AI satellites, and those are going to function as orbital data centers, leveraging Starship for that high-volume, low-cost launch. There's a couple of reasons why moving data centers to space has some pretty immediate advantages over building them here on Earth, which takes us to our next limiting factor, and that's power generation. Because guess what? It's always sunny in space. Satellites can harness near constant solar energy. I mean, you're tapping into an energy source that becomes the only way to scale if AI continues to grow at the pace that it is, especially when you contrast it with all of the challenges we see here on Earth. Within about 2 to 3 years, we believe space-based AI compute will become the lowest cost option as launch costs drop and Earth-based power constraints grow. So it's going to just transform how our planet powers AI. And to unlock all of that, we get to our third limiting factor. We need to make significantly more chips, and we got to do it fast. And that's where we're going with Terafab. This is going to be the most epic chip building effort ever. And we say epic. You just look at the scale of this thing. That's the size of a Tesla Gigafactory, about 10 million square feet. We need to think bigger. We're looking at about 100 million square feet, so you're talking 10 gigafactories worth of space. It all sounds a bit fantastical, a bit out there, but all of this together represents a step towards becoming a galactic civilization, harnessing more power from our nearest star, supporting the reality-shifting AI applications that are coming, and advancing humanity's multiplanetary future. So if you want to learn more about that, you can watch that full conversation on our website at SpaceXAI/StarMind. So a lot of really cool stuff coming. Kate, future looking pretty sweet, but first things first, Flight 13.
Yeah, you're absolutely right. The future is built on progressive steps like today's test. Now, let's dive into the flight profile.
Right, so today we'll be starting with liftoff of Pad 2 here at Starbase. Super Heavy will ignite those 33 Raptor 3 engines, and we will then power through ascent ahead of our hot stage separation, which is when the booster will shut down all but 5 engines at the bottom. Stage 2 will then light its own Raptor engines, pushing off of Super Heavy and starting that hot stage separation. We will then have the directional booster flip, with Super Heavy igniting those 33 Raptor engines. And after coasting for a few minutes, the booster will then target a landing burn and splash down a few miles off the coast of Starbase.
Ship keeps the fun going with its ascent burn to a suborbital trajectory. We then deploy those 20 Starlink V3 satellites, and we plan to relight a single Raptor engine. Re-entry then follows a few minutes later, which should provide some amazing views via Starlink of the ship's blistering re-entry through the Earth's atmosphere. A plasma blanket will form around the vehicle, and this never fails to provide epic scenes as the vehicle comes back. And lastly, we'll conclude today's test with a landing flip, landing burn, and a splashdown in the Indian Ocean. And with that, let's kick it back up to Dan for a countdown update.
Hey, thanks, Kate. Good news is very little news. We are continuing to look on track for a liftoff today, not tracking any issues on the vehicle or the pad side. Range status continues to be green. Reminder, we're tracking the range out in the Gulf off the coast of Starbase where we're launching over, and then also out in the Indian Ocean where we're hopefully sending a Starship in just about 11 minutes from now. Weather looks gorgeous. Blue skies, low winds, couple of clouds, not a concern for flight today. And again, the vehicle and the pad both looking great. We are in kind of the latter stages of propellant loading. We got into the go, no go with the flight control team at about T-minus 1 hour. And then we've been loading prop for about, quick math, about 26 minutes now. We're going to continue loading propellant, that's your liquid oxygen, your liquid methane, onto both of these vehicles until just a little over 2 minutes before we lift off. We'll close out on the ship at about 2 minutes and 10 seconds, and on the booster before that at about 2 minutes and 50 seconds. So at the moment, we're looking good. We're counting down to the very top of our window. It was a 90-minute window. It opens right at 5:45 p.m. Central Time. Looking good to hit that right at the top. Back over to you guys.
Thanks, Dan. Now, as teams prepare for today's launch from Texas, work is also continuing on the other side of the Gulf in Florida, where Starship will soon be launching, potentially later this year.
That's right. Starship flights from Florida will initially lift off from Launch Complex 39A at NASA's Kennedy Space Center. Teams are working through Starship system activations, performing initial tower chopstick motion tests, confirming the operation of the hold downs on the launch mount, and performing multiple integrated tests of the propellant farms, water farm, diverter, and launch mount. With Starship coming to 39A, the launch complex will soon have 2 operational pads for 2 very different rockets with Starship and Falcon Heavy. It has been awesome to see the 39A Starship program come to life over several years, and it's going to be exciting to soon see a Starship launch from this historic pad.
Yeah, we're super excited. But 39A isn't SpaceX's only pad in Florida. Just a few miles down the coast at Space Launch Complex 37, the first of 2 Starship launch pads at that site is quickly taking shape. Pad 37A is targeted to be ready for flight operations early next year, which is very fast considering we only started construction on the pad in November. This year, teams have worked through ground preparations at the pad and fuel farms while also fully excavating the flame trench for Pad 37A. In June, stacking began of the launch and catch tower, and you can see that there on your screen. And we have plans to complete that stacking in the coming weeks.
And a few miles west of Pad 37 is our Cape Giga Bay, where all Starship vehicles in Florida will be processed for flight. Recently, teams finished erecting all of the building's steel and are now working to finish the exterior of the structure. In the coming weeks, SpaceX will complete activation of the first crane in the building, set up the first integration stands, and complete platform work to be ready for supporting the first Starship vehicles that will arrive in Florida. We'll transport the rockets from Texas to Florida, and honestly, it's just going to be so exciting to see a Starship take flight from the Space Coast. Especially exciting as I had the opportunity to play a role in the Starship Cape program in my previous role, so
That's pretty awesome.
pretty awesome.
Yeah. Clearly, SpaceX's future in Florida is coming together quickly with planned launches already on the horizon, including regular trips to the moon. And speaking of the moon, NASA recently announced the Artemis 3 crew for the next moon mission. Let's head back up to Dan for more on that.
Yeah, thanks, Kate. I mean, we're not going to take a minute. We're not going to take a minute to nerd out a little bit about the moon. So NASA just announced the Artemis 3 mission. That's going to be a crewed demonstration flight into low Earth orbit designed to demonstrate a lot of the critical systems needed for future lunar landings. We've got our astronaut crew, 3 from NASA, 1 from the European Space Agency. Randy Bresnik, Luca Parmitano, Frank Rubio, and Andre Douglas are going to crew that mission slated for 2027. That's going to be the penultimate mission, the final test before Artemis attempts to put astronaut boots back on the moon for the first time since 1972. For our part, we're going to be launching a Starship with a docking port on the nose so we can practice rendezvous and docking with the crew inside of Orion. One of our key test objectives is going to come after docking, where we're going to be able to test out the maneuverability of both vehicles while they're connected. This has some extra importance as the revamp plan for the Artemis landing missions are going to use Starship to do the burn that sends astronauts to the moon from Earth orbit. And one other cool ad that just came out today, NASA is going to be putting 2 SpaceX mini lasers on Orion to connect it to our Starlink constellation, where we already use thousands of lasers today. And they're going to be doing that with the goal of enabling 4K imagery and video from the spacecraft while they're in space. So a lot of excitement planned for next year as we all work together to send humans back to the moon, begin building a moon base, get to that future where anybody that wants to go to the moon is going to hopefully be able to go to the moon. So lots of really cool stuff to come. For now, though, we're at T-minus 6 minutes, 18 seconds into today's launch, and we're getting into terminal count. So let's zoom in. So range continues to be green. Weather continues to be gorgeous. We are getting into the final stages of propellant loading on both stages of Starship. Again, we're putting liquid oxygen, liquid methane on both the booster and the ship. Ship has main tanks. It also has those small header tanks in the very top and the nose of the vehicle that we're going to fill up. We're going to close out on the ship at about 2 minutes and 10 seconds before launch, and then the booster at about 2 minutes and 50. Once we're completely done prop loading, you've got about 11.5 million pounds of liquid propellant on board both stages. Then we start to get the pad itself ready for launch. We do what's called pushbacks. That's you're clearing out all of those propellant feed lines that have been flowing from the tank farm into the tower, into the vehicles, push it back into the tank farm, and then we also start purging all of those lines with an inert gas, just getting it ready for launch. We'll do final thrust vector steering controls on our Raptor engines at about T-minus 100 seconds and then T-minus 60 seconds. If a hold is needed, shocking change, it's now going to come at T-minus 60 seconds. That's a new time. We've balanced out a couple of our final checks that happened before liftoff, and we moved them a little bit earlier before we start flying. So that time is now at T-minus 60. That's the point where we can pause to wait. We'll only hold there if there's an issue, and we can recycle back.
Minus 60 seconds passes, a number of events will occur in rapid succession. Both the ship and booster will configure their comm systems for flight and will rapidly run leak checks on gas and fluid tanks. The booster will also go to internal power and its engines will get its final priming for launch, while the ship's engines begin their ascent bleed profile and it arms the automatic flight safety system. There's a lot of mechanical activations on the tower side as well, with one critical step, unlatching the quick disconnect feeding propellant into the ship.
And once T-minus 60 seconds has passed, there is still the ability to rapidly recycle the count under certain conditions back to that T-minus 60 second hold point. We can hold there and assess what happened and if teams can proceed again to T0. We've got about 5 to 8 minutes of hold time, and that will largely be driven by the propellant temperatures that we see on the vehicle while holding. The flame diverter on pad 2, which you can see the side profile of it there on your screen, that activates at T T-minus 17 seconds. And if we trigger a hold after that, it will result in a scrub for the day. So we're now just under 3.5 minutes until liftoff. If you've recently joined, we're planning to deploy 20 of our Starlink V3 satellites. These are real V3s on board, so that's exciting. We also would like to perform a Raptor in-space relay as well.
That's right. And actually on the screen now, you're seeing an awesome view of our pad and the clouds that you're seeing coming off of our fuel tank farm, all now being used for its second time here for Flight 13.
All right, so we're through the 3-minute mark. So we should be closing out prop load on the booster any second now. And then the closeouts on the ship will come just a little bit after that. Again, we're looking a little over 11.5 million pounds of propellant on both of these vehicles. We are not currently tracking any holds on the board, which is always good news. Reminder, we have that built-in hold at T-minus 1 minute. We're only going to stop there if we run into an issue where we need a couple of minutes to hang out. But right now, we have no holds on the board. So a lot on deck for Starship, the second flight of Starship version 3. Booster version 3, Raptor 3, looking to get off the pad here in 2 minutes. All right, so we are closing the fill drain valves for both vehicles. So we have finished out our propellant loading. 33 Raptor engines right there at the bottom of the booster getting ready to light up. Final wiggle checks happening now. You can see those inner 13 engines moving. Those are the ones that Super Heavy is going to be using to steer, do all its maneuvers. We just got through those. Okay, so we are 1 minute, 20 seconds away, counting down. We're going to listen in. Again, not tracking a hold, so we should move right past T-minus 1 minute. If we recycle back to it, we'll figure out why, and then we'll continue counting down. So let's go. T-minus 1 minute. Let's listen in. Let the rocket do the talking. See if we can get a Starship off the pad today. We did trigger a hold. So again, we have this hold built in. We've got a couple of checkouts that are going to happen on the vehicle and the pad that we've got to clear. A lot of it's tied to essentially the different pressures that are in the systems that are feeding prop into the vehicles. Looks like we are getting ready to reset that hold though. And the clock is rolling. And we did trigger a hold right at startup there. You saw we got a hold on the booster. So stick with us for a second.
Go.
So we did trigger a hold on the booster that aborted our liftoff as we were starting to light those Raptor engines. As a reminder, since we already turned the diverter on, we are going to be scrubbed for the day. The team's already starting to pull for offload of both vehicles, so starting to get the prop off. We'll take a little bit of time to look into what triggered that abort. Usually we'll take some data review for all of our teams. But again, we did abort on the startup of the booster. So we weren't tracking any holds moving in to those final seconds into that final minute. But that is going to be a scrub for the day. So the team's now moving into commodity offload. We're going to take the methane and the oxygen off of both Starship and Super Heavy. So not the end result you're looking for, but we've got vehicle there still on the pad, and they're going to get these commodities offloaded. We'll take some time, dig into what triggered that abort once the booster was igniting to launch, and then we'll figure out what our path forward is going to be. Again, if you're just jumping in, we're not going to be launching today. We got all the way down to startup, triggered a hold on the booster, and that shut down the engines right as they were starting to ignite. All right, so at this point, they're going to get into offload. We're going to get all the methane, all the oxygen off the vehicle, and then we'll figure out next steps. So, no Starship launch today. We'll dig in with the teams, figure out what happened, and figure out when our next attempt is going to be. And obviously, we're going to keep you updated as well. So we'll dig into what our recycle time is, when we're going to be able to try again. Be sure to follow us on X at SpaceX. We're going to share updates there as soon as more information becomes available and when we can get back for flying. So thanks for tuning in today. Hopefully, we'll be back real soon for Flight 13 and another attempt to get Starship off the pad. Thanks, everybody.